Namaste. Welcome to video lecture series on chapter periodic table of an element. In this video, that is video number 5, we are going to discuss about what are the demerits. What are the demerits of Mendeleev's periodic table? Now, in a previous two videos, we had discussed about what is Mendeleev's periodic law, what is Mendeleev's periodic table, and what are the merits of Mendeleev's periodic table. Now, in this video, we are going to focus on demerits of Mendeleev periodic table. Please do remember, he was the first person who successfully classified 63 elements. Despite limitations are more, but this was a very first ever scientific approach towards the classification of element. He successfully made classification of element which were known at that time. So credit is more than to discuss these demerits, but as a part of syllabus we need to know these demerits also. Now, very first thing about the position of hydrogen. Now, if you recollect, in a second video while discussing about Newland's law of octave, there also we stated same thing. The hydrogen position is still uncertain. Even same issue will come across here. Even in modern periodic table also will face the same issue, that hydrogen position is still uncertain. Because hydrogen, if you look at here, it's been placed along with alkali metal, but it also shows a similarities with halogen. It also shows a similarity with group 7 element, that's an halogen. So as per this, it can be placed at two different places, but here it has been placed only with alkali metal, that is with group 1. So that was a limitation as such. Even same limitation has been present in modern periodic table also. Now, the second one, as we discussed about Mendeleev periodic law, which states that properties of an element are periodic functions of its atomic weight. That means I have arranged element in increasing order of its atomic weight. I have arranged element in increasing order of its atomic weight. But if we carefully look at certain places, certain places, the element with the higher atomic weight has been given first priority than the atom with lower atomic weight. That means the higher atomic weight element precedes and the lower atomic weight follows it. So the first example which we come across here is cobalt and nickel. If you carefully look at this position, actually cobalt should come after nickel. That means nickel should be ahead, because nickel's atomic weight is 58.71 and then cobalt should follow. But in order to adjust the properties, these are slight adjustment in terms of position of an element has been done. So cobalt, which has got atomic of 58.93, has been placed ahead of nickel, which has got atomic weight 58.71. A same problem comes with a tellurium and iodine. The tellurium and iodine. Now, if you carefully look at, the tellurium has got atomic weight 127.6 and iodine has got 126.9. So officially iodine should come first, followed by tellurium, but it has not been seen there. In order to accommodate the property of an iodine in that particular group, the iodine has been given the next place and tellurium has been pushed ahead. So this is, at some places we'll find out that atom with a higher atomic weight gets priority over the lower atomic weight element in order to adjust the properties of that particular element in that group. In order to fit that element in a particular group, these adjustments have been made. Now, we have seen here, as per the classification, the element possessing same property, so it should come in a same group, we can say. Uh, so here we come across this particular thing like isotopes. Now, if you look at here, isotopes basically have got same chemical property. Isotopes have got basically same chemical property but different atomic masses. So, if you carefully look at this particular Mendeleev periodic table, there is no way I can place a hydrogen isotopes. The isotopes do not find any place because here if I have a hydrogen, then next I should have the isotopes of hydrogen. I should have isotopes of carbon. I should have isotopes of oxygen. I should have isotopes of chlorine. But as this periodic table is based on atomic masses, isotope also should be placed, but there is no placement for isotopes of an element is been done. So there is no provision is been made to provide a space for isotope. Then we have certain elements which are possessing similar chemical property. We have certain elements which are possessing similar chemical property. They have been placed at two different places. They have been placed at two different places. So if you try to look out the copper, if you try to look out copper, now copper and mercury, copper and mercury, which possesses similar property, but they have been placed at two different places. Copper and mercury, which possess the same property, they have been placed at two different places. One copper I placed here in first B group, and mercury has been placed in second B group. We can say here you have mercury. So if you look at these two positions, they are different. Actually, they should come together. Then, if you look at carefully over here, I have lithium, sodium, potassium. Now these are three elements possess the same property. They are reactive. But along with that, if you observe, I have copper is been placed, silver is been placed, and gold is been placed. Now there is an greater difference in the reactivity of these six elements. I can say lithium, sodium, potassium, they are highly reactive. Copper, silver, gold, they are least reactive, but somehow they have been placed together. So elements with the different properties have been placed together, and elements with the similar properties are placed at different places. So this serves as a drawback for Mendeleev's periodic table. Then it does not provide any information about electronic configuration of an element. See, here he talks only about how the property changes with the changes in atomic weight or atomic mass, but it didn't give any information about anything in terms of electronic configuration. So these are the few limitations of Mendeleev periodic law and Mendeleev periodic table, but still the credit is for systematic classification of element at that time. He has been considered as father of periodic table because no doubt he was too genius. He left some spaces in his periodic table for a yet to discovered element, which has give acceleration to the discoveries of to the research work more. So taking all these things into consideration, hope you must have understood this explanation for drawbacks of Mendeleev periodic table. Thank you for watching.